Antarctica, the southernmost continent on Earth, is a land of extremes. Covered in ice that's miles thick, it's the coldest, driest, and windiest place on the planet. But what lies beneath this icy expanse? For centuries, Antarctica has been a source of mystery and fascination, and scientists are only beginning to uncover its secrets. From hidden lakes and ancient fossils to mysterious subglacial mountains and potential extraterrestrial clues, Antarctica holds a treasure trove of discoveries waiting to be explored. In this video, we'll dive deep into what's hidden under Antarctica's ice, exploring the science, the mysteries, and the implications of these findings for our understanding of Earth's history and future. Chapter 1. The Ice Sheet, a frozen time capsule. Antarctica's ice sheet is the largest single mass of ice on Earth, covering about 14 million square kilometers and containing around 60% of the world's fresh water. But this ice isn't just a static blanket. It's a dynamic, ever-changing layer that holds clues to Earth's past climate. Scientists drill deep into the ice to extract ice cores, which act as time capsules. These cores contain trapped air bubbles, dust, and other particles that provide a record of atmospheric conditions dating back hundreds of thousands of years. One of the most significant discoveries from ice cores is evidence of past climate change. By analyzing the composition of the ice, researchers have reconstructed temperature and carbon dioxide levels over millennia, revealing patterns of natural climate variability. This information is crucial for understanding how human activities are influencing the planet today. But the ice sheet isn't just a record of the past. It's also a key player in Earth's future. As global temperatures rise, Antarctica's ice is melting at an accelerating rate, contributing to sea level rise. Understanding the dynamics of the ice sheet is essential for predicting how much and how quickly sea levels will rise in the coming decades. Chapter 2. Subglacial Lakes, Life in Extreme Environments. One of the most fascinating discoveries under Antarctica's ice is the presence of subglacial lakes, bodies of liquid water trapped beneath miles of ice. The largest of these is Lake Vostok, a massive lake buried under 4 kilometers of ice. Scientists estimate that Lake Vostok has been isolated from the outside world for millions of years, making it a unique environment for studying extremophiles, organisms that thrive in extreme conditions. In 2012, Russian scientists successfully drilled into Lake Vostok, retrieving water samples that contain microbial life. These microbes have adapted to survive in complete darkness, under immense pressure, and with limited nutrients. Studying these organisms can provide insights into the limits of life on Earth and the potential for life on other planets, such as Europa, one of Jupiter's moons, which is believed to have a subsurface ocean. But Lake Vostok is just one of hundreds of subglacial lakes in Antarctica. Each of these lakes could harbor unique ecosystems, offering a glimpse into how life can persist in some of the most inhospitable environments on Earth. The discovery of these lakes has also raised questions about how they formed and how they remain liquid despite the freezing temperatures above. Chapter 3. The Gamburtsev Mountains, a Hidden Range. Beneath the East Antarctic ice sheet lies one of the most mysterious geological features on Earth, the Gamburtsev Mountains. Discovered in 1958 by a Soviet expedition, this subglacial mountain range is roughly the size of the European Alps, with peaks reaching up to 3,000 meters high. Yet, despite their size, the Gamburtsev Mountains remain almost entirely hidden from view, buried under kilometers of ice. The origin of the Gamburtsev Mountains is a puzzle for geologists. Most mountain ranges form through tectonic activity, such as the collision of continental plates, but the Gamburtsevs are located in the middle of a stable continental craton, where such activity is unlikely. Some scientists speculate that the mountains could be remnants of an ancient tectonic event, while others suggest they may have formed through processes like rifting or volcanic activity. Understanding the Gambotsev Mountains is important not just for geology, but also for climate science. The mountains play a key role in shaping the flow of the ice sheet above, influencing how ice moves and where it accumulates. As the climate warms, the stability of the East Antarctic ice sheet could be affected by changes in the underlying topography. Chapter 4: Ancient Fossils. Clues to a Warmer Antarctica. Antarctica wasn't always a frozen wasteland. Millions of years ago, during the time of the dinosaurs, the continent was much warmer and covered in lush forests. Fossil evidence from this period has been found in the Transantarctic Mountains, including the remains of dinosaurs, early mammals, and even ancient plants. One of the most significant fossil discoveries in Antarctica is that of the Glossopteris plant, which thrived during the Permian period around 300 million years ago. The presence of Glossopteris fossils in Antarctica, as well as in South America, Africa, India, and Australia, provided key evidence for the theory of continental drift, the idea that Earth's continents were once joined together in a supercontinent called Pangaea. More recent discoveries include the fossils of marine reptiles like plesiosaurs and mosasaurs, which lived during the Cretaceous period when much of Antarctica was covered by shallow seas. These fossils provide a window into a time when Antarctica was teeming with life, offering clues about how ecosystems respond to climate change over geological timescales. Chapter 5: Extraterrestrial Clues, Meteorites, and Beyond. Antarctica's icy surface is also a prime location for finding meteorites. The continent's dry, cold environment preserves these space rocks, while the movement of the ice sheet concentrates them in specific areas, making them easier to find. Over the years, scientists have recovered thousands of meteorites from Antarctica, including rare specimens from the Moon and Mars. One of the most famous Antarctic meteorites is ALH 84001, a Martian rock that sparked controversy in the 1990s when scientists claimed it contained evidence of fossilized microbial life. While the claim remains debated, the discovery highlights the potential for Antarctica to yield clues about the possibility of life elsewhere in the solar system. In addition to meteorites, Antarctica's ice may also contain cosmic dust, tiny particles from comets and asteroids that have fallen to Earth over millions of years. By studying this dust, scientists can learn more about the composition of the early solar system and the processes that shaped it. Chapter 6: The Future of Antarctica, Challenges and Opportunities. As scientists continue to explore what's hidden under Antarctica, they face numerous challenges. The harsh environment makes fieldwork difficult and expensive, while the remote location limits access to many areas. At the same time, the continent is increasingly vulnerable to the effects of climate change, with rising temperatures threatening to destabilize its ice sheets and disrupt its ecosystems. Despite these challenges, Antarctica offers unparalleled opportunities for scientific discovery. From understanding Earth's climate history to searching for life in extreme environments, the continent holds the key to answering some of the most pressing questions in science today. As technology advances, new tools like satellite imaging, autonomous underwater vehicles, and advanced drilling techniques are opening up new possibilities for exploration. But Antarctica is not just a scientific frontier. It's also a place of international cooperation. The Antarctic Treaty, signed in 1959, designates the continent as a place of peace and scientific collaboration, setting aside territorial claims and banning military activity. As we continue to explore Antarctica, it's essential that we work together to protect this unique and fragile environment for future generations. Conclusion: Antarctica is a land of mystery, where the secrets of Earth's past and the potential for future discoveries lie hidden beneath miles of ice. From subglacial lakes and ancient fossils to hidden mountain ranges and extraterrestrial clues, the continent offers a wealth of opportunities for scientific exploration. As we uncover these secrets, we gain new insights into our planet's history, the limits of life, and the challenges we face in a changing climate. But Antarctica is more than just a scientific laboratory. It's a reminder of the beauty and fragility of our planet. As we continue to explore this frozen frontier, let's remember the importance of preserving it for future generations. Thanks for watching, and don't forget to like, share, and subscribe for more deep dives into the mysteries of our world. See you next time.